My name's Ingrid. I'm the Paddock to Reef coordinator with Reef Catchments. I sit in the Proserpine area. I just want to welcome everyone to the virtual 2020 Mackay Whitsunday Regional Integrated Science Forum, COVID-19 style. This event is facilitated by Reef Catchments through funding from Queensland Government and the Australian Government. So under the original scope of the Regional Integrated Science Forum, we would hold a face-to-face forum annually in April, and unfortunately due to COVID we had to change this into 4 sessions of Zoom forums instead, and this is the final session of those 4. The objectives of the forum is to deliver current and relevant information about Paddock to Reef and Reef water quality improvement plan programs, whilst communicating the OGBR science and relevant reef report cards. As I said, this is our final presentation in our fortnightly series that virtually replaced our planned Mackay event in April, and Kim Clyden is a veteran host of many events over 30 years and will be our facilitator for today's event.
Hi everyone, it's great to have you joining us today. Firstly, today we'd like to kick off with a message from the Traditional Owners Reference Group.
My name's Samala Deshong. I'm a Coomera woman. My country is situated from Cape Palmerston to St Lawrence in the Mackay Whitsunday Isaac region. I've been an active member for the Reef Catchments Traditional Owner Reference Group since it was started in 2006. I'd like to acknowledge the traditional owners of the land we stand on in Mackay, the Yuwibara people. We'd like to pay our respects to our elders, past and present. The 7 tribal groups in the region are Yuwibara, Coomera, Burradabana, Widi, Gia, Naro and Juru. A lot of us are on the coast. We are saltwater people. The Great Barrier Reef is important to the region's traditional owners. It's food source. We've got the islands. We have stories way back that are brought down to us. A ceremony performed, men's business. So there's a lot of reasons why, we look after the reef. A lot of the catchments are nurseries, the seagrass beds are nurseries for, some of the fish, shrimp and that come from the reef. It's important to look after land and sea country. We've been brought up to look after country. That's why it's very significant to the traditional owners looking after land and water. We need water to regenerate. If it didn't, Mother Earth would die. So it's important for us to share our knowledge and work with Western science to help look after country for future generations.
A big thank you to Samala Deshong there. Today's 1-hour session features Angus Thompson, who will take us through a comprehensive overview of the who, what, how and why of monitoring coral condition, followed by our second presenter, Jackie Shields, working with and coordinating volunteers collecting vital information on intertidal seagrass cover. Angus Thompson is a marine biologist and coral ecologist, the AIMS coordinator for Inshore Coral Monitoring. AIMS, of course, is the Australian Institute of Marine Science, located just south of Townsville. For more than 10 years, Angus has monitored reef fish communities on the Great Barrier Reef as part of the Longterm Monitoring program. In 2004, however, his focus shifted to the monitoring and reporting of coral communities in inshore areas under the Marine Monitoring program. In these roles, he has developed skills in the design of monitoring programs, the analysis, interpretation and reporting of coral community condition, and an appreciation for the need of sound data management and quality control systems. With an interest in understanding the pressures that determine coral community condition in inshore waters, Angus embraces the synthesis of results, which has led to the use of report cards to educate diverse audiences. Contributing to many publications during his career, Angus continues to share his 30-year knowledge and experience to improve conditions in marine environments. Please welcome Angus Thompson.
So yeah, as Ingrid said, I'm going to quickly run through the coral data that goes into the report card scores for the regional report card, and this is all very similar data that goes through into the reef level report card. So a quick outline, I'm going to cover the providers because there's multiple people and programs that contribute to the coral scoring in the report cards in the Mackay-Whitsunday-Isaac region. I'm then going to have a quick run over the indicators that we use to assess the coral communities, and then provide a summary of the condition for the 2019 reporting zones, and then cover off with a quick assessment that we've seen in surveys this year, post the sort of 2020, early 2020 bleaching events. So jumping right in, this is the marine reporting zones in the Mackay-Whitsunday-Isaac region. Offshore, there's the big multicoloured one coloured part, that's the offshore zone. Then on the inshore, there's a northern, which you can see up here, a northern zone, a Whitsunday zone, a central zone sort of off Mackay, and then down more towards Shoalwater Bay, the southern zone. And each of these zones have different programs operating and providing information. In the northern and the central zones, the data comes from North Queensland Bulk Ports and James Cook University, who together have the Ambient Marine Monitoring and Research Program. You will note that in the northern zone up here, the sites at Holborn Island are actually in the offshore zone, and this does reflect some of the scoring in that zone compared to other inshore areas. In the Whitsunday area, this is where the Marine Monitoring Program, which is a collaboration between the Marine Park Authority and AIMS, sits. And this is the program that kind of developed the report card scoring, and has led to some of the methods being taken up by the other programs. AIMS also has the Long-Term Monitoring Program, which has been going on the offshore reefs since 1992, in these areas up here, the green ones, and some of those reefs are also in the Whitsunday zone. And these reefs down here were started in about 2005 to look at the effects of line fishing. And then in the southern zone, reef catchments, the Healthy Mackay-Whitsunday-Isaac Healthy Rivers to Reef Partnership has kicked off the Southern Inshore Monitoring Program, which AIMS collects the data for. In each of these zones, we report on a set of coral resilience indicators. So the simplest one, of course, is coral cover. The more coral you have, the better the score. And all of these scores range between 0 when they're in really poor condition and 1 when they're in really great condition. And then when we average up these scores for each of the indicators, we get to the report card score that you'll see in report cards. The juvenile density, we look at the density of juvenile corals on the substrate. This gives us an idea of the ability of coral communities to recover once the adults have been killed by cyclones, crown of thorns, bleaching events, things like that. Again, this one runs from 0, when there's just no juveniles at all, through to 1 at a capped thing of 16 per metre squared. This is a pretty high abundance, and anything over that is just a bonus, but you really don't need any more than 16 per metre squared to have a really healthy community. The cover change indicator, this assesses how quickly coral cover is changing, so how quickly it's growing in between disturbance events, and this lets us give an idea of the recovery potential again. We then also look at macroalgae, only on the inshore zones. We don't report it in the offshore zone because it's generally low offshore and of no consequence for the resilience of the reef. But we do impose location-specific guidelines to this one because, as you can imagine, once you get really close to the coast, the macroalgae, that's where it naturally lives. And as you get further out to the coast, then you get to more coral reefs habitat. So we try and adjust for that in our scoring of the macroalgae. We also have a composition score. This is only done in the Whitsundays inshore zone, and we're looking at change in community composition. based on what we saw in the early years of our monitoring. So the current situation, or the 2019 situation that you'll see in report card scores, has to be taken into context of some of these recent major disturbances. Now, the Mackay-Whitsunday-Isaac region, you know, if you're looking, around here, then the 2016 and 2017 bleaching events, red means there was a significant amount of bleaching, green means it was okay. So there was a bit of bleaching off Mackay observed in 2017, but the big one was Cyclone Debbie, which pretty much everyone will be quite familiar with. And also for the southern zone, Cyclone Marcia, which I don't have on this map. When we go to the offshore zone, we can see that over time, there has been a trend of, it started off in pretty good condition, but then we got Cyclone Hamish and Louis came through, and if you look at this blue line, the dark blue line that I'm tracing with the pointer, you can see that they really knocked coral cover down. And at the same time, we lost juvenile corals out there as well. Since then, we saw a recovery in the index as juvenile densities recovered. We saw an increasing rate of cover increase, but that's still reasonably low. This 0.4 is the range between orange here, which is very poor condition, or poor condition and in a report card sense, and moderate condition as yellow. But you can see that coral cover has stayed pretty flat since those cyclones, and part of that reason is that we've had subsequent Cyclone Marcia and Debbie, which weren't big effects offshore, but they did knock the coral cover back a little bit. But we've also had crown of thorn starfish in low numbers sort of persistently moving around through these reefs, and that's sort of kept everything low and probably keeps this cover change metric a bit low as well. But the positive side is that this cover change metric is now sitting up in the moderate zone, and juvenile densities are really high. So there is that recovery potential still on the offshore reefs. When we come inshore, the Whitsunday Island area, where we have the longest time series, Cyclone Louis knocked it back a little bit, but then it started to recover and was actually in good condition prior to Cyclone Debbie, which had a catastrophic effect on the inshore reefs. And there was a bit of an improvement in scores for macroalgae, but that's because the cyclone stripped the macroalgae off the reefs as well as the corals. And so that rapidly grew back, which is why, and in fact is higher now than it's been in the past, which is why that macroalgae score is declining. This continued decline represents the fact that some of these reefs are only surveyed every 2 years, and it took several years before all the post-cyclone observations were in. But really what we've got now is a poor condition. We've got the cover change metric has always been pretty low and is really tanked. The juvenile densities are low, and this macroalgae, which is a bit of an indicator of nutrients in the system, is also declined. So it's a bit of an example for what's going on during that cyclone. This is Double Cone Island, just that you can see if you look straight to the north off Ellie Beach. And you can see prior to the cyclone, 2015, 2016 was the same, really high coral cover. This is exactly that same picket after the cyclone. It's just all gone. And we lost 97% of the corals that were at that site during the cyclone. And by 2020, this is still that same picket. There's been no recovery at all at that reef. And that's at 2 meters depth. Once we go a little bit deeper, different coral community, but the same thing, got wiped out by the cyclone and is not showing much recovery. There are patches of coral at 5 meters because that was a little bit below some of the wave action, but it's still pretty dire. And then when we go, this is the macroalgae. This is at Daydream Island just a couple of weeks ago in the shallows. This site prior to the cyclone had a really high cover of nice branching acropora coral, and it's now looking like this. I think coral cover there is, less than 1%. When we go to the northern zone, it's a much shorter time series up there. We only kicked that off in 2016. AIM sort of kicked this off and then it was taken over by JCU. what we're seeing here, Cyclone Debbie, again, was the response to the initial decline. We are seeing a slight increase in cover change, but it's still low. Coral cover is still very low, and juvenile densities are really bad. And so that's really suggesting that there's not so much ability for those reefs to recover rapidly at this point. When I mentioned that those Holborn Island reefs in the northern zone sat in the mid-shelf or the offshore kind of zone, that's partly why this macroalgae cover is getting a good score in this area, because there's 4 sites out at Holborn compared to just 2 at Camp West, and at Camp West there is very high macroalgae. And that isolation of Holborn kind of out in the shipping channel is probably partly the reason why the juvenile densities are so low, because there's just no broodstock anywhere near it. In the central zone, these are the reefs sort of straight off Mackay out to Keswick. Then you can see that the condition has been continually low. Cyclone Debbie had a little bit of a drop down in coral cover, but really what's driving those low scores is high macroalgae cover, which gives a low score, and low densities of juvenile corals, which macroalgae are kind of reinforce that situation. In the southern zone, we only have 1 year of data, so I didn't bother trying to make a plot of it. There was some good reefs down there, some good coral cover at Henderson, and even in at Aquila and at Temple Inshore. But really what was really driving the score there was that macroalgae was super high at a lot of the sites, and juvenile densities again were very low. And to give you a bit of an idea of the reefs down there, when we were down just recently, we had a drone with us so we could get some nice shots. This is at Pine Peak, which is in the Percy group. It's about 50 kilometres off, or 50 miles offshore. And you can see this has got a very large reef flat, which means that since the sea level rose about 10,000 years ago, the coral community here has been really healthy and been able to build this big carbonate substructure. And if you look at the side, sort of around the boat, all these roundish patches, they were all live coral bommies that have been growing on this reef flat. But currently, you can see a few little white patches, which are bleached corals. And what it looks like underwater, all that dark country, it's not live coral, it's all algae. So there's lots and lots of sargassum out there, which is this big brown algae, and that really limits recruitment and is limiting the recovery of corals. There's still corals there, but they're not recovering. They're struggling against that algal competition. What's happened since is that if we think of these bleaching back in 1617, which were those really large events that we've heard a lot about in the media, you know, the green here, the temperatures, you can see, if you look here, this is the temperature stress, and it's up once you get into the green, yellows, that you start getting coral mortality and bleaching. So you can see that you're pretty spared. But this year, 2020, we're right up here into these warm colours, and so the bleaching was quite evident. And this is the reef with the highest coral cover, Henderson, down in the down again in that inshore of the Percys this time. All that white there is not sand, that's bleached coral. And so when you get underwater, this is what it looks like. A lot of the corals are completely bleached. Some are regaining their cover, so they're probably okay. Bleaching covered a range of different coral communities, different types of coral. And if we look at this photo, you can see the effects of the bleaching running through. We have corals here that in circles, these are recently dead. These will have died as a result of the bleaching already. So this is not dead very long. It's got very little algae growing on it. It's probably only been dead a few weeks. We've got corals that are fine. They've got good coral. They've got good zooxanthellae. That's the algae within the coral that gives them their energy. And then we have these white corals that are still bleached. The temperature hasn't been hot for sort of 3 or 4 months prior to this photo, and they're still in the bleached state, which means they're starving. The algae that are in the fine corals give them their energy, and they're just sitting there waiting either to take up that algae or die effectively, because they'll be starving. They'll be using up their fat content to stay alive at the moment. So conclusions, the offshore reefs have been impacted by several cyclones and crown of thorns, but they really maintain that ability to recover. But once we come inshore, we've seen some really severe disturbances in recent years. And we've got low densities of juveniles and high macroalgae cover pretty much across the board. And that's really limiting the potential of those inshore reefs to recover. So it's quite worrying. And that limited ability to recover is especially concerning given the high temperatures that we saw and the impacts of bleaching. So these bleaching events, there's now been 3 on the Great Barrier Reef in the last 5 years. You know, that's just too frequent for the recovery for these corals. So all in all, it's not looking great on the inshore reefs at the moment. There are some recruitment going on, but that macroalgae is really limiting what's going on. And so I've run over time fractionally, sorry for that. Thanks to the contributors, the Healthy Rivers to Reef Partnership, the Marine Park Authority, Queensland Bulk Ports, James Cook University, and Sea Research, who actually does the surveys for James Cook University. Thank you.
We're moving on to Jackie Shields. She's a marine biologist, dive master, and guided water tourism advocate, voluntarily coordinating volunteers in Pioneer and Hideaway Bays. Today, Jackie will share the story of how the Whitsunday site's data is gathered, verified, and used by scientists and government management agencies. Take it away, Jackie.
My name's Jackie Shields. I've been coordinating the Whitsunday Seagrass Volunteers since 2009 as a volunteer. So I started off as a volunteer and then I became a volunteer coordinator. And we monitor the condition of local seagrass habitats using the Seagrass Watch monitoring protocols. And first, a little bit about seagrass and why we do this. So next slide, please. People tend to focus on the reefs of the Great Barrier Reef, but they don't exist in isolation. Coastal seagrass habitats are a vital part of the Great Barrier Reef Marine Park, and they support iconic species. They also support coastal seafood species, and they help maintain water quality that's critical for the health of inshore reefs. In return for all that they give us, seagrasses need specific conditions to survive. So they have high minimum light requirements. They also need some nutrients. They need carbon dioxide. They need a suitable substrate to grow in, which is usually sand or mud or somewhere in between. They need the right salinity for the species. So some can handle almost fresh water, some up to 4 times the concentration of seawater. And they need temperatures not to be above 38 degrees Celsius. And for the intertidal species, that's air temperatures as well as water temperatures. There are plenty of threats to seagrasses. Water turbidity from sediment runoff reduces light levels and slows their growth. Elevated nutrients cause algae to outcompete and smother the seagrasses. This picture is a good example. Coastal developments can completely remove seagrass habitat. Physical damage from anchors, boat propellers, moorings, and other human activities. And also, of course, climate change, which leads to higher temperatures and more frequent extreme weather events, as Angus mentioned. The seagrass resources in northern Queensland weren't formally surveyed and mapped until the mid-1980s. There was rising public concern in the 1990s about local impacts on seagrass habitat, and people were more aware of seagrass value as habitat and as fish and prawn nursery grounds. So at the time, the Queensland DPI established the Seagrass Watch Community Seagrass Monitoring Program to address some of those concerns. Starting in 1999, monitoring in our area was carried out by the Whitsunday Volunteer Association, which at the time was supported by the Queensland DPI, who provided the program and the training, and the Queensland Parks and Wildlife Service, who provided in-kind support and a part-time coordinator to manage the program. In about 2005, due to changes at QBWS, the Whitsunday Volunteer Association was wound up. The Hideaway Bay and Pigeon Island sites were still monitored by the volunteers, but other sites gradually got suspended as without support of QBWS, the program lost momentum. In 2009, I became volunteer coordinator, and in October 2012, we organised a state government-funded training course with DPI Seagrass Watch. It was good timing because in November 2012, the Newman government closed down the DPI Marine Plant Ecology Group. Luckily, the core of the group found a new home at JCU in Cairns, but Seagrass Watch as a program was now unfunded. We had to pay for any future training, and we're also left without any public liability insurance to operate. And just as all the government support for the citizen science programs dried up, various agencies started reporting on the status of coastal habitats in the Great Barrier Reef World Heritage Area. And the reports demonstrated a lack of data on the status of seagrass habitats in some areas. The Whitsunday Seagrass volunteers were approached by staff from Reef catchments looking for seagrass data. Eventually, this led to Reef catchments helping Whitsunday Seagrass volunteers to run another volunteer training course, with an additional contribution from the Gabrumpa Whitsunday Local Marine Advisory Committee. The Whitsunday Seagrass volunteers affiliated with Ouch volunteers to allow us to access the free Queensland Water and Land Care insurance. We also had to carry out a complete overhaul of our 1990s vintage paperwork and operating procedures to comply with the in-safe hands procedures used by other volunteer groups. The Seagrass Watch monitoring method we use is intertidal. Volunteers walk out onto the seagrass meadow at low tide, lay out transect tapes and quadrats at fixed sites. For each site, volunteers collect data from 3 transects with 11 quadrats along each. Every quadrat is photographed for quality control. There are normally 2 sites at each location. The information recorded is sediment composition, percentage cover, species breakdown, canopy height, algal cover and epiphyte cover. If time and volunteer numbers permit, we also collect seed cores, which provide an indication of reproduction and the status of the seed bank in the meadow. Whitsunday Seagrass volunteers use the scientifically validated Seagrass Watch monitoring protocols. Seagrass Watch HQ, now at James Cook University, is the core of the program. Their role is to develop the protocols for monitoring, manage the database and validate the data, provide and develop training, coordinate communities and scientists, facilitate the establishment of networks, and continuing the development and expansion of the program. Seagrass Watch HQ currently carries out ongoing quality checks on all data submitted, ensuring the data is of high quality and that people's time and resources are not wasted. Whitsunday Seagrass volunteers have altered the timing, location and frequency of our monitoring to better meet the requirements of the marine monitoring program. In 3 consecutive days of monitoring in May and September, we currently monitor 2 sites at Bowen Main Beach, at Hideaway Bay and Pioneer Bay. We've also helped Reef catchments in establishing a new monitoring site at the Isaac Council area at Clairview, where there had been no monitoring previously, and to resume monitoring at a suspended site at St Helens Beach near Mackay. Reef catchments now provide in-kind support to the Whitsunday Seagrass volunteers and are recruiting a growing group of volunteers to monitor the sites in the Mackay-Isaac region, which Cass Haywood coordinates. Support from Reef catchments has enabled the Whitsunday Seagrass volunteers to have more trained volunteers, monitor more sites and provide data that is able to be used in current reporting programs such as the Healthy Rivers to Reef report cards and the Marine Monitoring Program. This data provides evidence to support the government funding allocated to on-ground work on improving water quality in our region in programs such as Paddock to Reef. The next few slides are some examples of the data that's been collected by Seagrass Watch, analysed and prepared by staff at Seagrass Watch HQ. The traffic light coloured indicators show the condition of the seagrass meadows in terms of percentage cover of seagrass for 2019-20. White indicates a lack of data, so those are sites that are dormant. The Whitsunday Seagrass volunteers are currently doing Bowen, Hideaway Bay and 2 of the 4 Pioneer Bay sites in Cannonvale. Mackay volunteers do Clairview and St Helens Beach. Seagrass Watch HQ staff, QPWS and JCU do the remainder. This is the data collected by Whitsunday Seagrass volunteers over time. Sorry about the scale, I know that that's quite small, but it goes back to round about the beginning of the program. From the long-term monitoring, you can see that the seagrass cover over time on the Whitsunday sites has generally reduced, and you can actually see the dips after the extreme weather events from 2010 to 2013, which for our area included Cyclone Alui, Cyclone Oswald in 2013, and then there's a gradual recovery until Cyclone Debbie in 2017. And there's some signs of recovery on some sites after Cyclone Debbie, but it is slow. This is data collected by Seagrass Watch HQ, JCU and QPWS. which shows a fairly similar pattern. Some of the sites, the JCU and the TPWS, are very recent, so it's not quite as clear. This is the long-term trend in seagrass abundance over time since the beginning of the program. So it has, since 2009, really not recovered fully to what it was before the extreme weather that we had in 2010, 2013. This is only up to 2019 because the 2020 data hasn't been processed yet. The green shaded area is a 95% confidence interval. So seagrass abundance has improved slightly since Cyclone Debbie, but it's still way below the 2009 levels. Overall indications that seagrass abundance in the Mackay-Whitsunday region in 2020 was in a fair state, and that's mainly due to the slight recovery after Tropical Cyclone Debbie. The Seagrass Watch HQ have a website, and they also have newsletters and all sorts of information on their website. So if you're interested in finding out more about seagrass, it's a great place to start. They're in the process of updating it, so looking forward to seeing more there. There's actually a seagrass spotter app as well, so if anyone wants to do a bit of citizen science themselves, you can take photos of seagrass where you see it and upload it to the app. The Seagrass Watch website is a great resource for educators as well, and it's also a contact point for potential volunteers. So you can find a group there, but also Whitsunday Seagrass Volunteers have our own Facebook group and our own mailing list if anyone is interested in joining us. Many changes to habitats are only visible in hindsight when it's too late to act, or through long-term monitoring. As the name suggests, this has to be for the long haul, beyond the usual timeframes considered by government and staff on short-term contracts at government-funded organisations. Given enough support, citizen science programs like Seagrass Watch can survive changes in government policy and priorities and keep providing data sets over long periods. Whitsunday Seagrass Volunteers and Mackay Seagrass Volunteers are groups of people who care about their local environments and who, with a little training, are providing valuable data to managers on the condition of their local seagrass habitats. In addition, participating in citizen science networks like Seagrass Watch develops groups of local people who are learning about their local habitats and who care what happens to them. That's it from me.
Jackie Shields, you've been fabulous. Thank you very much for your time today. And thanks to everyone who has joined us. Just recapping on what you've seen today in conclusion, apart from thanking Angus and Jackie and congratulating them on their first virtual Mackay Whitsunday Regional Integrated Science Forum. If you have any further questions, please send them directly to Jackie, Angus, or the RCL staff who've organised this event. As mentioned previously, if you missed it, publishing any of the information disclosed during this event will require the express permission of RCL and individual government media approvals via their departments, or as in the case of Jackie and Angus, their individual organisations that they work for. Angus covered off on the marine scores for coral, offshore reefs impacted by several cyclones, and crown of thorns starfish maintain the ability to recover, but scores remain similar to the 2018 levels. The Inshore reef, severely impacted by Cyclone Debbie and likely Cyclone Marshall with the southern inshore zone, is confronted by a macroalgae continuing to decline. Low densities of juvenile corals and high macroalgae cover limit recovery potential at many inshore reefs, and they were represented from 2-metre depth offshore in the Whitsundays and, of course, inshore, I should say, and Daydream Island, plus Holborn and Mackay Islands and south to the Persees. Jackie, of course, 21 years watching the grass grow. Can you imagine? Seagrass cover. She was outlining seagrass growth requirements and, of course, the threats to their very being. The project began monitoring seagrass in 1999 with interesting and vital insights shared. Jackie joined the team in 2009 and, to her credit, is still there. Under great duress, I imagine, trying to encourage and sustain volunteer numbers. The importance of engaging and training volunteers across multiple sites over long periods. Of course, the citizen science and social media aspect of that as well was presented. She's also told us how the data gathered is verified and distributed, then used by agencies and managers in government positions. The use of data in reports cards to inform government and the public, and the changing cover of seagrasses, trends, threats, impacts on marine species, etc. I hope you've enjoyed that presentation today. I am Kim Clyde, and it's been a pleasure delivering these 4 fortnightly sessions. I'll hand you back now to Ingrid, who is part of our hosting team, thanks to Reef Catchments Limited.
Thank you today for attending the final session of our virtual forum. Thank you for being patient with us with our few technical issues that we had for today's session. We seem to manage and work through them, so well done to the presenters. And I'd just like to thank everyone involved, particularly our presenters. So without our presenters, we wouldn't be able to go ahead with these events. Thank you to Kim, our facilitator, and the Rooster, who played a big part in today's session. And thank you to our audience that are tuning in every fortnight. Thank you to Samala for the wonderful acknowledgement of country video that she put together before this session started. Thank you to the working group, and thank you to all involved in helping put these presentations and forums together. It's been a little bit of a challenge, more than expected, but once again, thank you. If you've got any feedback or questions, please do reach out to the presenters or myself or other the Reef Catchments organisation. And stay tuned for recorded events to be shared on the Reef Catchments YouTube channel. We've already got the first session on the Reef Catchments YouTube channel already. So thank you.